Hello, we are the students of the third course of St. Petersburg Electrotechnical University. We are studying at the Faculty of Biotechnical Systems, Department of Bioengineering Systems. Department of Biotechnical Systems is the leading one in Russia. It prepares specialists of medical and technical profile. Graduates from the bioengineering systems are the high-class specialists in the field of biotechnical systems and technologies. Basic Department of Biotechnical Systems is located in the medical center named after Almazov, where students of the department can use their knowledge on practice. We have decided to tell you about our project that we conduct at the faculty with the use of biomechanics in particular.
3D model of human's head structure, construction method. Actuality. Nowadays, a traumatic brain injury is one of the most prevalent injury type and has 50% of all the human injuries. That's why TBI is becoming a crucial issue for a wide range of research papers in medicine and mechanics. For brain damage analysis, computer modeling of human head based on finite elements method is used as an instrument. The model built by this method allows to make a biomechanical analysis of a human head condition injured by a kick and may be used for potential trauma prediction by transit loads. The aim of our project is to develop a human head model to make an analysis for a specific human based on their medical photos and data, to learn how the head will behave under the pressure in real time in dynamics. The goals of the research are to create a step-by-step algorithm of 3D model of human head construction and to study all the necessary computer program kits.
At the moment, almost all the scientific articles about modeling and researching of traumatic brain injury use the head model present by Royal Institute of Technology. A model based on the method on finite elements was developed in 2002 in Stockholm. The Royal Institute of Technology's model includes head skin, a skull, a brain, meninges, cerebrospinal fluid, 11 couples of large sagittal veins, and a neck with extension for a spinal cord and dura mater. However, this model doesn't allow to take into account individual features of a patient. The significant advantage of a new methodology is that the model becomes individually and anatomically detailed. The developed algorithm contains several stages. The first, viewing a series of CT scan and MRI images of the patient using specialized computer program DCOM Viewer. The second, creating a 3D model. The third, selecting the type of tissue using different setting of the filter, value of density of the tissue. The fourth, removing other structures which won't be in use. The fifth, exporting surface to STL format with choosing optimal parameters, count of the iteration of smoothness, and maximum count of the polygons. Then, checking the created surface and error correction in the polygons using MeshLab. Next, importing the file to the SolidWorks, creating a solid model of the element, connecting elements together. The last, creating the model of the human skin using the same algorithm. To create the solid model of brains, another method is required. The model is being created using extrusion from sketches in the SolidWorks program. The sketches can be obtained from CT scan or MRI section, which are located equidistantly from each other. Later on, brain's cortex and cerebrospinal fluid will be created. When all separate parts are connected, the model will be ready for test with different types of load.
So, using this method, the content model of the human head with places for fixing or loading was developed. This model includes a skull, a brain, a soft and solid cerebral membrane, a cerebrospinal fluid. Some assumptions were developed, such as the material of each element is homogeneous and isotropic. There are no initial stresses, and moreover, the geometric shape of the constituent model is simplified. Now, The process of creating the model depends on the number of choosing structures, which may take a lot of time, requires medical knowledge and work skills, not even in one, but in several computer programs. The developed algorithm will simplify this process and accelerate the transformation of the medical image into the model ready for analysis of its mechanical properties, considering individual characteristics of the patient. In the future, it will be possible to develop human brains not as a single organ of the human body, but as a combination of the several structures with different mechanical characteristics. We will be very glad to see you at our faculty. You can see bachelor and master programs on the screen. Some of them you can study in English. Thank you for your attention.